Today we're going to speak about the infinite geometric series. What's an infinite geometric series? It is when you want to add a geometric series, but it does not have an end. It does not have a certain amount of terms that you want to add. It goes on forever. When we need to find the sum of an infinite geometric series, we use the rule. What is the rule? S, and remember there is no n here because there is no certain amount of terms. It goes on, so it is infinite. Equal a1, which is the first term, over 1 minus r. Provided the absolute value of your r is less than 1, which means that the r is a fraction. If the absolute value of the r is bigger than 1, then the series has no sum. Let me have those two examples to show you why. This first example has 2, 4, 8, 16, 32, and so on. The r here is 2. I cannot find the series, I cannot find the sum of those. Why? Because it goes on and it's bigger. It's getting bigger and bigger and bigger and bigger, and I don't know where it ends. While this one, 32, 16, 8, 4, 2, 1, it gets smaller. And for the infinite answer, because the r is less than 1, which is half, I'm going to have at the end, I'm going to have a very, very tiny answer, which doesn't really matter in your sum. Let me find the sum of an infinite geometric series. Those are two examples. Let's see. Summation notation, n, which is the first term, up to the infinity, and then 2, which is the first term, between brackets, r to the power of n minus 1. See, the r here is minus 5 over 4. Is that less than 1 or more than 1? It is less than 1, but when we put the absolute value, it becomes more than 1. So accordingly, it has no sum, because the absolute value of the r is bigger than the 1. Let me see the other one. I equal 1, and it's also up to infinity. 3, this is my a, and then 1 over 4, that's my r, to the power of n minus 1. This is your r, which is 1 over 4. Is it less than 1? Yes, it is. The absolute value of 1? Yes, it is. So accordingly, I can plug them in my rule, and then I have 3 over 1 minus 1 over 4. I get my answer to be 4. Example 3. If I do have a1, and the sum of the infinite geometric series is 4, I don't know the r. I'm going to find the r by putting both answers, a1 and the s, into the rule. S, 4, a1, 7, 1 minus r. By plugging them in, I'm going to have my answer as 3 over 7. 3 over 4, sorry. How can we use the geometric series, the infinite geometric series, for writing a repeated decimal as a fraction? If we have 088 and it goes on forever, how can I do that? How can I answer that? I need to know, originally, was it an 8 over 10? No, because 8 over 10 is only repeated once, while 888, it is repeated forever. So I'm going to assume that my first term is 8, 0.1, which is 0.8. And my second term is 0.08. My third term is 0.008, and it goes on. So my first term, a times 0.1, my r is 0.1. I'm going to put them in this rule. I'm going to find a1, 8, multiplied by 0.1 over 1 minus 0.1. I get my answer, 0.8 over 0.9, which is 8 over 9. What if you don't have only one repeated? You have a double repeated, which is 0.71 repeated. Is that over 100? No, it is not over 100. Let's see. The same thing. Take the first 2 after the decimal and put them as your first term. And then each one of them is the one next to it. So 71 over 100, and those 71 are over 10,000, and so on. So my r is how many numbers? 2. 0, 1. Remember, when it was 1, it was 0, 1. When it was two numbers, it was 0, 0, 1. See the difference? Okay, so your R will differ according to the number of repeated terms. And then you're going to have A1, which is 71 multiplied by 0.01 over 1 minus R. When you put it there, you're going to have 0.71 over 0.99, which is 71 over 99. What if you do have a number first before your repeated term? And it so happened that the number is the same as your repeated term. You're going to assume that the 27 is your A and the 0.01 is your R. Nothing happened as long as the 27 is repeated again and again and again. The same thing exactly is happening. A1 over 1 minus R, 27 over 1 minus 0.01. You get your answer 300 over 11. Is this a fraction? No. It is an improper fraction. Why? Because you already have a 7. 27 here. 27 is a number. So you originally should have a number first and then a repeated fraction. What if the number is different? 4.21 and then the 21 is repeated. What are you going to do? You're going to take the whole 4.21 as your repeated term, and then you're going to ask yourself, two numbers, then it has to be 0.01. This is your R. And then you plug them in your rule, and you get your answer. 421 over 99.